Our focus standard for this lesson comes from Grade 8 Expressions and Equations, Standard 8. Analyze and solve pairs of simultaneous linear equations. Our topic for this lesson comes from our new unit, Systems of Equations, Analyzing Systems of Equations Word Problems. Our essential question is, how can we interpret systems of equations to solve word problems? Please take a moment, pausing the video if you need to copy the standard, the topic, and essential question into your header, along with today's date, set of your question column, and your note column, and resume the video when you're ready to begin. We're going to start off today by discussing the 4 steps to analyzing systems of equations word problems. The first step is to identify the 2 relationships being compared. Second, we want to match each relationship to the correct line on the graph. Third, determine the solution, and by solution we mean the point of intersections between the 2 lines. And fourth, we want to further analyze the graph to fully answer the word problem. Please take a moment to make sure you have these 4 steps copied down, and then we'll begin to work on the example problem. In our example today, Jill is planning to go on a shopping trip to the outlet mall, but since her car is broken, she needs to use a cab service. In the following equations, C equals cost and M equals miles. The equation for the first company is C equals 2M plus 2. While the other company's equation is C equals M plus 5. Using the graph, answer the following questions. So it's important to have this word problem copied down in your notes so that you can refer back to it later. So take a moment, pausing the video if you need to make sure you have the full problem copied down. And then we'll move on to looking at the graph and the questions we'll need to answer. Before we do anything more with this problem, we first want to make sure that we're identifying the 2 relationships being compared. We want to stop and say, what am I looking for? So we are given 2 equations, which is really nice. Oftentimes we'll have to write them, but here we're giving 2 equations. And what do they represent? Well, it tells us C equals cost, so we're looking at the cost, and we're looking at the cost for 2 different cab services, right? So in identifying the 2 different relationships being compared, we're looking at the cost in relationship to the miles being driven for each of the 2 different cab services. So always important that when you're approaching a word problem, after you read it, to really stop before you do any work and analyze what information do I have and what do I need, what's happening in the story. Now that we have that, let's take a closer look at the questions they want us to answer. So first they want us to figure out which equation matches to each company. So we know the first equation is C equals 2M plus 2, where the other equation equals C equals M plus 5. So we have a yellow cab and we have a blue cab service. Which line matches to which company? Or which equation matches to which line? Take a moment copying down this graph and also writing down this question, and then go ahead and write in what you think. The biggest hint is that these equations are in y equals mx plus b form, so because they have different b values, we can look there. Here, our first b value is 2, positive 2, and sure enough, the y-intercept right here is 2, and it represents the yellow cab. Meanwhile, on the other equation, our y-intercept is 5, and here we see that represents the line for the blue cab service. So it looks like, just based on the y-intercepts, that the yellow line would be for C equals 2m plus 2, would represent the equation for the yellow cab, and C equals m plus 5 would represent the blue cab. To be perfectly sure, we can double check with the slope. So this has a slope of 2, meaning its rise is 2 and its run is 1. And so sure enough, it looks like it's going up 2 over 1, up 2 over 1, up 2 over 1. It is slightly off, but that's probably because it was made with a computer and not by hand, so it's a little bit, but it definitely follows that general trend. Whereas c equals m plus 5, remember, if there's no number, there's always a 1 hiding there. And so that means the rise is 1 and the run is 1. And from that 5, sure enough, it looks like it's going up 1 over 1, up 1 over 1. And so definitely the blue cab is the equation c equals m plus 5, whereas the yellow cab is c equals 2m plus 2. So we've identified the two different relationships, the cost of the blue cab and the cost of the yellow cab in relationship to the miles, and we've matched which equation and which line goes to which company. Now we're ready to determine the rate of change in the determine what the rate of change in the y-intercept mean in the context of this situation. So the slope is comparing our rise over our run, right? And on the rise is our y change. So the y is the cost, and the x is the miles. And so our rise and our run is telling us how much does the cost increase, both of these are increasing, based on the number of miles that you're driving. So for every mile, how much does the cost increase? Then we have to think about, well, what do these y-intercepts mean? What does this 5 and the 2 mean? So it's saying at 0 miles, the yellow cab costs $2 and the blue cab costs $5. What it looks like to me is that it costs just $2 to even call the yellow cab company and order a ride, where it costs $5 to call the blue cab company and order a ride without just to have them come pick me up. And then the slope, the rate of change, is telling me how much is that going to increase for every mile that I go on the trip. So if we're writing that out, here it is written in what I just explained. Our rate of change, or our slope, our rise is the change in the y, which is representing the cost in dollars, and the run, which is our change in x, that's representing miles. So that 1, remember we said there's a 1 hiding there, it means that it's going up $1 per mile. $1 per mile. Per is going to be a really key word throughout this unit, so you may want to highlight that. And again, we're talking about the blue cab. So the y-intercept is that $5 just to call up and order the cab to have them come pick me up. And similar here to the yellow cab. This 2 in our rate of change, again, y is the cost, x is the miles. So that 2 is saying that it cost me $2 per mile that the trip is, and that it costs, the y-intercept tells us that it costs $2 just to order the cab to come pick us up. Now we just have 2 more questions. At how many miles will the cost be the same for the 2 cab companies? Well, this is asking us for our solution, right? So while they've marked the solution on our graph, go ahead and see if you can write that down. What are the coordinates of the solution to the systems of equations? Looks like right here is that point of intersection. Remember, that's our solution. So the solution is here at 3, 8, when x is 3 and y is 8. And so if we interpret that in the context of this problem, the 3 is our x is miles, so it looks like at 3 miles, the 8, which is our cost, at 3 miles, both companies will cost $8 total. Lastly, we want to decide how should Jill decide which company to use. So this is that last step in really further analyzing this graph to make sure that we're answering the questions and that we can be as detailed as possible in our answers. And so if you're leaning towards, well, it depends, you'd be absolutely correct. Because if Jill is only going to go if Jill is only going to go 3 miles, if that outlet mall is only 3 miles from her house, it really doesn't matter which cab she uses because it's going to cost the same. However, if the mall is only a few miles, if it's only 1 or 2 miles from her house, the yellow cab, which is down here, this is a lower cost. So if it's only 1 or 2 miles away from her house, then the yellow cab would be a better choice because it's cheaper. But after 3 miles, if that outlet mall is 4 or 5 or 10 or 20 miles away from her house, the blue cab is going to be the better deal because although it costs more to order it, they only charge $1 per mile. So after 3 miles, the blue cab becomes a better deal because they are cheaper. So again, we've kind of written that out. You might have written it out in your own words there. But this is our first step into really digging deeper into our systems of equations and looking at them in the context of word problems. And so you really want to make sure that your notes are fully complete. This is going to be a good one for you to come back to.